In lesson IA 13, we're going to continue working with rational expressions that we started in the last lesson. It's going to continue to be important to talk about domain exclusions. We always have to be concerned about that. But in this lesson, we're going to do both multiplication and division. We're going to start with multiplication. Your steps. You're going to factor all numerators and denominators. So that should mean that you have 4 different polynomials that potentially can be factored. The next step, you're going to go ahead and determine the domain exclusions. Remember that the denominators cannot equal 0. So you set the denominators equal to 0, solve those, they become your domain exclusions. Then you're going to simplify, and I put in quotes the word bow tie, so hopefully you remember from arithmetic that if you had 5/16 and you multiplied it by 8/20, that you need to reduce, and it is a good idea to do it before you multiply. So I will say, looking at this diagonal, that 5 goes in here once and 5 goes in here 4 times. Then I will look at this diagonal and say 8 goes in here once and 8 goes in here 2 times. Go ahead and look up and down because that's a possibility also. Multiply what's left over in the numerators. 1 times 1 is 1. Denominators, 2 times 4 is 8. Now, in this case, I have shown you that you can reduce, simplify before multiplying. If I had just multiplied 5 times 8, I would have gotten 40. And 16 times 20, I would have gotten 320. And then I would have needed to reduce this, which might have taken me several steps. I still would have gotten to 1/8. My point is, it is usually easier to do the reducing either, and I'm going to use a highlighter, maybe. You look this direction, you look this direction, you look this direction, you look this direction to see if you can divide out a common factor. And because of the shape of those directions, I nickname it a bow tie. So if I say bow tie your product, I'm implying look this way to see if you can reduce, look this way, look up and down on both ends. Okay, let's go ahead and start our first problem where we're going to be doing this with polynomials. All right, problem number 1. As I write down these fractions, down here, I'm going to go ahead and factor as I do it. The numerator of the first fraction, x minus 6, cannot be factored, so I will put it in parentheses, x minus 6. The denominator has a common factor of 3. So I will call it 3 parentheses x plus 2. When I factor 3 in there, I get x. When I factor 3 in there, I get 2. Next one, I have 4x plus 8, which has a common factor of 4. And when I divide 4 into each of those, I get x plus 2. Denominator, I have a common factor there of 4. And 4 goes in there x times, 4 goes in there 6, so it's x minus 6. Before I do my reducing, sometimes called my canceling, I want to look at the domain exclusions. For the first one, 3 is not a problem because it cannot equal 0. But if x plus 2 is 0, that means x is negative 2, and that is a domain exclusion. Do not let x be negative 2. On the second denominator, 4 can't ever be 0 But if x minus 6 is 0, that means x is 6. So when x is 6, this denominator goes to 0. That's a domain exclusion. So back up here in the answers, before I've done my simplifying, I go ahead and say x cannot equal negative 2 and x cannot equal 6. So I check those before I do any reducing. So now, to do my reducing, I'm going to use my red pen. I see a common factor of x minus 6 and x minus 6. Looking on this diagonal, I have a common factor of x plus 2 and x plus 2. Don't forget to look up and down, and I have a common factor of 4, although I don't usually write them down. Every time you divide out a common factor, you are leaving ones behind. So that if everything is divided out, it's really a product of 1 times 1 times 1, which is numerator of 1. Denominator, I have 3 times 1 times 1 times 1, which is 3. So this fraction simplifies to be 1/3, and the domain exclusions are negative 2 and 6. All right. When they say simplify, that's absolutely the correct language, but I am like many of you. I most probably will slip and say reduce to lowest terms, because that is another way to say it. All right, let's look at our second problem. All right, in my simplifying, the first thing I'm going to do is factor. The let me write this. I've got one fraction times another fraction. Looking at this numerator, it's no common factor, but it's a binomial. It's the difference of squares. So I will factor it into x plus 9 times x minus 9. The denominator, I can't do anything with. I'll leave it as x squared. The numerator of the first, I see a common factor of x. That's x times x minus 9. The denominator, that's a trinomial, so I'll go ahead and put my parentheses. The last sign is negative. That means 1 plus, 1 minus. I've got x and x. I need factors of 90 that have a difference of 1, so hopefully you're thinking 9 and 10. I will let the 10 be positive and the 9 be negative. We can check that. Before I go any further, I stop for the domain exclusions. The first one, if x squared is 0, the only thing that makes that true is x is 0. That's a domain exclusion. For the second denominator, I have x plus 10 times x minus 9 equals 0. So x plus 10 equals 0. X is negative 10. X minus 9 is 0. X is 9. I have a single domain exclusion from the first denominator, but I have two domain exclusions from the second denominator. So up here in the answer choices, I'm going to say x can't be 0, x can't be negative 10, x can't be 9. It doesn't matter what order you put those. Now it's time to reduce, so I'm going to grab my red pen. I have a common factor of x minus 9, and I have a common factor of a single x here, and I'm going to take one of these and just leave a single x, and I think that's all I can divide out. So back to black pen. In the numerator, I have x plus 9 times x minus 9. In the denominator, I have x and x plus 10. This is my simplified answer. These three are my domain exclusions, so I will have x plus 9 times x minus 9 over x times x plus 10. Leave that in factored form. Don't multiply it out. So you can see there's quite a bit of work involved in these problems. Lots of factoring. Let's look at the next one. I'm going to, get rid of that. I'm going to first look at my simplifying. And if I'm going to simplify, I have to factor the top and bottom of the first and the top and bottom of the second. Let's look at the numerator of the first. X squared minus 4. Hopefully you recognize that as this difference of squares. So I get x minus 2 times x plus 2. The denominator, let me get rid of that. Whoops. All right, give me just a minute. All right, forgive me just a minute. We've got something on the screen I need to get rid of, and it is not going away nicely.